Good day, grade 9s. This will be the last video that I'll be making on the chemistry, so I really hope that everything up to now has helped you to understand the chemistry a bit better. In this last video, we're going to look at how to balance equations, and this is actually what a lot of your questions in tests and exams is going to be, and everything kind of leads up to this part. So if you pay attention and you understand this last video, then it should put you in a fairly good position for tests and exams. But first, let's look at the questions that you had to answer from the previous video. So you had to give the name of the following chemical formulas. So in this first one, we have KCl. Now K is a bit of a tricky one since the symbol is not the letter that the element starts with. So K is for potassium and Cl for chlorine. And remember, the second part of the name requires a bit of a change. So we change the INE of chlorine with an IDE. So it's potassium chloride. Then the second one, we have magnesium fluoride. And then the third one, we have copper and oxygen. But remember, copper is a transition metal with variable valency. So we have to figure out what variant was used. Now in this case, it's fairly simple, since if you go look up oxygen on the periodic table, you would see that it has a valency of -2. And since oxygen is -2, that must mean that copper would be +2. So if you combine the two, then you get copper 2 oxide. So very important, the 2 Roman numeral 2 in brackets. Then the same thing for lead sulfide. Now sulfur also has a valency of -2, but in this case there's 2 atoms of sulfur. So that means in total this valency is actually -4. So you would require lead of +4 in order to balance out the sulfur. So the variant of lead used in this case is lead 4 sulfide. Then we have iron oxide, and in this case it's a bit simpler. So here we have, we just take this 3 over to the iron and this 2 over to the oxygen, and oxygen has a valency of -2, which means iron would have a valency of +3. So it is iron 3 oxide. Then copper chloride, but this is, you actually find different examples of copper chloride. So in this case it is CuCl2, which means it is going to be copper 2 chloride. And then right after that we have CuCl, and this one would be copper 1 chloride. So now you can see through these examples over here that it's very important that you work back and you find the correct valency that was used in order to correctly identify the variant that was used in this specific chemical formula. And then for the last two, we are working with polyatomic ions. So in this first case, we have beryllium sulfate. So SO4 is sulfate. So again, you must study and remember the names and the chemical formulas of the polyatomic ions. And then the last one, we have silver nitrate. So again, here we have a variable valency of +1, so it's silver 1 nitrate. And nitrate, again, you have to study and remember NO3 is nitrate. Okay, so let's go on to the work for this video. So in this video, we are simply going to try and balance the chemical equations. So that's the purpose of this video. So at the end of this video, you should be able to say, yes, I can balance equations. Okay, so in order to balance equations, you need to use a skill that we learned a bit earlier on, and that is to calculate the number of atoms in a molecule. So let's look at this example of 2H2O, and let's calculate the number of atoms in this formula. So if we look at hydrogen, then we see that there's 2 atoms in every hydrogen. So one molecule would have 2 atoms, but since we have the 2 in front, then we say 2 multiplied by 2, which is 4. So there's 4 hydrogen atoms in this molecule. And then the same for oxygen. There's 1 in each molecule. So then we say 2 times 1. So then we have 2 oxygen atoms. And then a little trick that we use, especially when we're going to balance the equations now, is to write down, to draw a little block like this and write down the number of atoms in each molecule. But you'll see now when we have the equations why this is important. Okay, so let's quickly look at when we have a bit more complicated molecule. So I'm using these placeholder elements again, X, Y, and Z, and just with some random numbers in there. So let's quickly see how do we calculate the number of atoms in this molecule. So we have a 2 in front, and then we have X3, and then in brackets, YZ3, and then outside of the brackets, 2. So the important thing to know is that the number, these small numbers only apply to the letter or the element after which it is placed. So this 3 over here only applies to the X, and this 3 over here only applies to the Z. But this 2 outside of the brackets applies to both the Z and the Y. Okay, so let's see how this plays out. So here we have a block, so we're going to write down the number of atoms for each of these elements. So for X, we have 2 times 3, so that is 6. And then for Y, we have 2 times 1 times 2, so that is 4. And then for Z, we have 2 times 3 times 2, which is equal to 12. Okay, so make sure you understand this, because these polyatomic ions with the brackets can make it quite complicated. So especially later on, if we're doing examples and you feeling a bit lost, then you can come back and look at this slide and make sure you understand it. So like I said at the start of the video, the purpose of this video is to balance chemical equations. But what is a chemical equation? Well, it is what we've been working with this whole time. It is the symbols that represents the reaction that is taking place. But these symbols just represent a specific chemical reaction. So a chemical reaction is a reaction of chemicals that results in the rearranging of molecular structure. So if we look at this example, we have X plus Y equals XY. So the compound or the molecules that goes into this equation rearrange themselves to form a different compound at the end of the reaction. And each reaction has reactants and products. And the reactants is just the chemicals that goes into the equation, so the chemicals that react, and the products is the chemicals that form as a result of the reaction, so the chemicals that come out. Now I always like to say that think of this as a recipe. So a chemical reaction is just a recipe, and the reactants is the ingredients that the recipe calls for. So the eggs and the flour that you put in. And then the products is the cake that you hope to get out of the recipe, or the whatever you hope to get out of the recipe. So if this was a recipe for cake, then the X would be the eggs, and the Y would be the flour, and the XY would be the cake. So the eggs and the flour is still there, they just rearrange themselves to now form a cake. So something that is very important when working with chemical equations is that the number of reactants and the number of products needs to balance, meaning what you put in needs to equal what you get out. So if we continue looking at the example of the recipe for cake, and the recipe calls for 2 eggs and 1 cup of flour to make 500 gram cake, then and you put in the 2 eggs and the 1 cup of flour, then you can't expect to open the oven and see a 2 kilogram cake, because that is not equal to what you put in. So the number of reactants or the ingredients needs to equal the products or what you get out. So let's look at an example of x2 plus y resulting in a compound xy. So if we look at this equation, then we can count the number of atoms on the left-hand side and the number of atoms on the right-hand side and see if they balance. So the left-hand side is the reactants and the right-hand side is the products. So if we look at the left-hand side, then we have x2, which means there's 2 x atoms, and just y, which means there's 1 y atom. And if we then look at the right-hand side, xy, that means there's 1 x atom and 1 y atom. Now, if you look at this, you would see that these are not balanced. The y atoms are balanced. You have 1 on the left-hand side and 1 on the right-hand side, but the x atoms aren't balanced. So you have 2 x atoms on the left and only 1 on the right-hand side. So what can we do to balance this? Well, very important is you cannot change the numbers at the end. You cannot change the small numbers, the subscript after the symbols. So these needs to stay the same. You're not allowed to change them. The only thing you are allowed to change is the numbers in front. So at the moment there's no numbers, but you can add numbers there. So let's see what we can do. So since the x atoms on the right hand side is half of the x atoms on the left hand side, it makes sense that we can double the number of x atoms on the right hand side. So we want this to be 2 over here, and we can do that by adding a 2 in front of the compound xy, and that is then going to result in x2 plus y resulting in 2xy, and that then means that there's now 2 x atoms on the right hand side. But the thing is, this 2 doesn't just change the x, it also changes the y. So now we have a problem again, because y on the right hand side is 2, while on the left hand side it is still just 1. So we can change that by adding a 2 in front of the y. So now we have x2 plus y2 equals 2xy, and now if we calculate the number of atoms, we see that they are equal on both sides. And so now we have balanced the equation. Okay, and then just again, it is very important that you are only allowed to change the number in front of the molecule. You may not change the numbers after the symbols. Okay, so let's look at our favorite real-world example quickly. H2O. So if you are given this equation, H2 plus O2 equals H2O, and you have to balance this. Now again, you can't just take these numbers away over here. Okay, this is the chemical structure of hydrogen is always going to be H2 because they are diatomic molecules. So that's something from grade 8 that you might remember. So this has to stay the same. So again, you must only change the numbers in front. So let's quickly see how it looks at the moment so that we can see what we have to change. So we have 2 hydrogens on the left hand side, 2 oxygens on the left hand side, 2 hydrogens on the right hand side, and only 1 oxygen on the right hand side. So what do we need to do? We need to increase the number of oxygen on the right hand side. And again, there's only one way we can do that, by adding a 2 in front. So if we do that, then hydrogen becomes 4 and oxygen becomes 2. So now we've balanced these two. That's equal now. Oxygen is equal, but hydrogen is not equal. So we need to balance this. So for that, we need to go back to the left-hand side. And what can we do? We can add a 2 in front and see what happens. So now we have 2H2 plus O2 equals 2H2O. And if we calculate the number of atoms, then we would see that now on the left hand side we have 4 hydrogens, on the right hand side we have 4 hydrogens, and on the left hand side we have 2 oxygens, and on the right hand side we have 2 oxygens. So these are all equal. So now this formula is correct and balanced. And that is it for balancing equations, or at least the theory of it. Now you need to apply that and see if you understand and you know how to do it yourself. So there's 3 homework questions that you have to do, each one getting a bit more advanced as we go on. So make sure, or practice this on your own, and make sure you know how to apply what we just discussed. So in this first one, I give you the full equation. So example, carbon plus oxygen equals carbon dioxide. So go calculate the number of atoms on each side, and if they don't balance, then balance them by changing the numbers in front. Okay, so write this down. Then for the next one. Okay, so for the second question, I give you the names of the elements and the compounds that form. So now you have to go look up the element on the periodic table, and then you have to figure out how they bind. So you can't just say LiCl. You need to go look at the valency for each of these and then correctly write this. So this might be correct, but I don't know. You need to go check on your periodic table and make sure you have the correct chemical formula. So this makes it a bit more complicated. So now it's applying both your knowledge from the previous videos and this video. And for the last activity, I give you the reactants, but I don't give you the products. So you again have to use your knowledge from the previous activities and videos first to figure out what the correct formula for this compound is, and then you have to go and balance it using your knowledge from this video. So this is probably as complicated as you will get it. So if you can do this, like I said at the beginning of the video, then you are fairly set for most of the questions that you will get in tests and exams. So write down all of the activities, make sure you can do it. I've got one more question, but this one is not compulsory. So this last one, like I said, is not compulsory, but I always like to throw this on the board right at the end once everyone has mastered balancing of equations and everyone is quite chuffed with themselves. Then I throw this one at them and I see who can get it first. So if you've done the other 3 activities, then try your hand at this one and see if you can do it. It's quite challenging, but it's also quite feels quite good when you do get it right. Okay, so I will make a video with all of the answers for this last activity, and I'll post that, but this is for now the end of chemistry. There's still some other theory, but that will handle a bit differently. So good luck.